Welcome back, everybody, to Integral Calculus Lesson 3. Right, I'm taking a question from the November series 2009 Cambridge AS mathematics paper, the code 9709. This is this is question 1. Okay, right. So, integral calculus. My name is Tabiso Miyataza. Let's get to it. Right then, this question reads like so. Okay, the equation of a curve such that dy dx is equals to 3 divided by root x minus x. So we have an equation of a curve dy such that dy dx is equals to 3 divided by square root of x minus x is given. Given that the curve passes through the point 4 and 6, find the equation of the curve. And this was worth 5 marks. Very good marks. Let's do it, and let's do it well. Let's get these marks. Get your own if you can. Right, let's do this. Right, so we are given another set of another piece of information here. This curve passes through the point 4 and 6. So we have a point at point 4 and 6. We are going to use that later. First, let us find the arbitrary solution to this curve that we are looking for. Before we even go there, square root there, I don't like it. Let's change it to be power half, or x to the power half. So dy dx, still we haven't integrated as yet, so I'm still writing as dy dx. All I'm doing is changing this to be x to the power half, and the second thing I'm doing is I'm taking this to the top. You don't have to, but it's simpler. Okay, 3x to the power minus a half, if I'm taking it to the top, minus that x there. Now it's in a nice format for me to integrate it. So dy is equals to all of this dx. Oops, I do beg your pardon. I am now talking about the fundamental principle of calculus. We will do that in the next, not the next lesson, but the other lesson, and I'll explain to you. For now, I'm not going to confuse anybody. I'm just going to write it as y is equals to, now I want to find the function f of x, or the function of x or y. Okay, so when we integrate, remember the rule: add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. If I add 1 to half, I get positive a half. To negative half, I beg your pardon. Negative a half plus 1, I get positive a half. So I have 3x to the power 1 over 2 divide by the new power, which is a half, minus integrating x, I add 1 to the power, so I get an x squared over there, divide by the new power divided by 2, plus an arbitrary constant c. Right, let's tidy this up before we can substitute our point 4 and 6 there that we are given. So tidying this up a little bit, we get y is equals to 3 times 2. Actually, what I'm going to do, I'm just going to write 6. 3 divided by half is 6. It's the same as 3 times 2. Square root of x minus 1 over 2x squared plus c. Okay, this, what we've got here, is the arbitrary solution. Arbitrary because of that constant c that is arbitrary. We don't know exactly where the curve is. We know the curve, we know the slope, how the slope is going to go, whether it's positive or negative. We can determine it from there, but we don't know what that point c is. So to do that, to help us find that point c, we are going to take this point 4 and 6 and we substitute it into that equation. Let's do that. Y is equals to 6, and that's equals to 6x minus half times x squared plus c, and our x is 4. So substitute your 6 and 4 into the equation. Solve that and you find that your C is equals to 2. Therefore, back substitute or substitute this new value of C into that constant C there. Therefore, your equation becomes y is equals to 6 square root of x minus a half x squared plus your value of C, which is 2. And that was the equation. Very nice. 4 marks for you to get in an exam there. Sometimes it might be 5 marks, depending on how hectic you have to navigate through your square root signs there. Okay, that was a nice and really simple and awesome question there. Right, now I'm going to take another question similar to this one from an alternate series paper. This is Cambridge again, paper 1 this time, 2007. Remember that this one is from 2009. I'm going to do a 2007 one. It reads thus: dy dx is equals to 4 minus x. So we are given dy dx is equals to 4 minus x. We are given an equation dy dx is equals to 4 minus x. I beg your pardon, I'm gonna write it just down there a little bit. dy much better, is equals to 4 minus x. Right, now we are also given that the curve from which this derivative was obtained from passes through the point 2 and 9, and we have a point 2 and 9. Find f of x, or find the function from which this was derived from. Similar question, again, 4 marks there. Okay, watch your time when you're doing these questions. Be careful, don't make mistakes, just hone up a little bit, have your brain cells all about you, and make sure that all the moving parts that you know can go wrong do not go wrong. Just tighten things up a little bit, but at the same time, pace yourself through this. Okay, watch your time. Okay, y is equals, now let's work out what our y is. This is a nice format to differentiate, to integrate this from, so I'm gonna go straight for it. So y is equals to integrating 4, again, I get 4 x to the power 0 plus 1, which is just 4 to the power 4x to the power 1, divided by the new power, which is 1, which is still 4x, minus x to the power 1 plus 1, I get an x squared, divided by the new power, which is 2, plus an arbitrary constant c. Good. I'm sure you can see from here what we're going to do. This is your arbitrary solution, but we want a specific solution because we are given a point where over which the graph passes through. 2 and 9 is our point for substitution. This time, substitute 2 and 9 into there. Your y is equals to 9, and that is equals to 4x minus x squared divided by 2 plus c. 4x minus x squared divided by 2 plus c. I beg your pardon, so your x there, let's substitute 2, and let's substitute a 2 there for x as well. Work out your c, and your c becomes 9 minus 6, which is 3. So c is equals to 3. So therefore, your new equation, or the equation that you are looking for, is given by y is equals to 4x minus x squared over 2 plus 3. And that, ladies, gentlemen, is worth a good 4 marks or 5 marks, depending on how hectic it is, as I said again. Okay, so The second part of this question here, they have a second part of that question. The first one, they said find the equation of the curve, which is what we were doing here. That was number one. The second part to that, they said the equation of the normal to the curve at P. So find the equation of the normal to the curve at P. Right. Find the equation of the normal to the curve at P. Now, what is a normal? That's what you're asking yourself right now. What is a normal? Right. A normal, let me just give you an illustration of this. The equation of the normal to the curve at P. If you have two lines, those intersecting each other at 90 degrees, those two lines, we say that they are normals to each other. Here you have a curve. Here you have a curve. We don't know how this curve looks like. Okay, there's the curve. Okay, so let's suppose there's a certain point P, which is 2 and 9. Point P there, which is 2 and 9. You want to find the equation of the normal to the curve at P. In other words, you want to find the equation of a line that intercepts the curve at that point there, P, at 90 degrees. Okay? The equation of the normal to the curve at P. You want to find the equation of a line that intercepts the curve at the point P, and where that point of intersection, they form an angle of 90 degrees. Okay, or they're perpendicular to each other. Now, going back to analytical geometry, we know our equations for normals and so on. There's several equations we are going to use here. The first thing, we know that if two lines are perpendicular to each other, then the gradient of line 1 multiplied by the gradient of line 2 must be equals to -1. That's the first thing. Now, you are hearing my talk right now. I'm talking of gradients. Gradient of line 1, gradient of line 2. So, okay, going from analytical geometry, I'm talking about gradients. Now, going into what we are doing now, integral calculus. Gradients basically means derivatives. Okay, gradients mean derivatives. So if we take it from there, this is how our solution is going to be. The gradient of the curve, the general gradient of the curve at the point P, let's find that first. We are given this, that's the derivative. Okay, now the general gradient of the curve at the point P, dy dx, which is the gradient at the point P. At P, x is equals to 2. That's going to be equals to 4 minus, substitute your x as 2 there. So the gradient at P, therefore grad at P, in other words, m at P is equals to positive 2. We want to find the equation of the normal to the point, or of the normal to the curve at the point P. The normal, then, we can find the gradient of that normal first. The gradient of that normal using that equation, the gradient of P times the gradient of the normal must be equals to -1. The gradient of P times the gradient of that line we are looking for must be equals to -1. The gradient of P is 2 multiplied by that line we are looking for is equals to -1. Therefore, the gradient of the normal must be -1/2. Okay, -1/2 is the gradient of the normal. This normal line, I've given it away. This normal line, it's a line, it's a straight line. Okay, Right, it's very funny that way. So, equation of a straight line. There are three basic, four, five, okay, three for now, basic equations of a straight line that we are going to use. Today we are going to use y minus y1 is equals to m into x minus x1. Just to remind you, we can use y is equals to mx plus c if we know the c there and if we know the gradient, which we do. Or we can use, if we don't know the gradient m, we can use this format but substitute m with y2 minus y1 divided by x2 minus x1. In this case, we do have m, we do know m, and we know one point that lies on the straight line that we are looking for. What is that point? Of course it is. It's that 2 and 9 there. Okay, it lies on the point. So y minus y1 is equals to m into x minus x1. This is our m. This is our y1 and x1. Let's substitute. Y minus value of y, 9, is equals to m, value of m for the normal, 1 over 2 into x minus, what's x1? It's positive 2. The rest, as they say, is maths. Solve this, you find your equation. Y is equals to negative half x plus 1 plus 9. Y is equals to minus half x plus 10 is our equation. Now, I get a lot of questions with some of these maths questions and like especially solutions there. For instance, one such question that I remember last year, if I can't remember, if my mind serves me correctly, was that will this be the correct format to present this equation that you are looking for? Because somebody wanted to really say to me, no, this was not the right one. They looked at the memo, and in the memo they were given something like 2y plus x is equals to 10. I am not going to go any further from there. I'm not going to insult your intelligence by even explaining this. I want you to look at those two equations, and I would like you please to write me a comment maybe, or just contact me and tell me what you think. Which one of those would be an acceptable format for exam presentation on your paper. Thank you guys so much for watching again, and hopefully I'll see you soon with another exciting, awesome lesson.